Hello, Assalamu alaikum.
عليكم السلام ورحمة الله.
Ar-Rahman-ar-Rahim. Okay, we are doing the chapter number 2, approximation of the nonlinear equation, the root of the nonlinear equation. The root we are now discussing is called the multiple root, and the condition for the multiple root I told you is what? F dash alpha must equal to the 0 here. But I told you when we say multiple root, it means it's repeating, and we also have to check how many times it's repeating. That's we call order of multiplicity. Order of multiplicity mean how many times our multiple root is repeating. And for this one, you remember last time I give you the two definition to check the order of multiplicity. One is by definition, which is slightly difficult to use it, is f of x is equal to x minus alpha power m into h of x here, where alpha shows the multiple root, m show the how many times it's repeating. This is called the order of multiplicity. H is a part of the function, but this part of the function does not have a multiple root. Therefore, h of alpha should not be equal to the 0 we have. Then I give you the simplest way to find order of multiplicity, which is this formula here. To find order of multiplicity, we have to take the highest derivative, continuously take the highest derivative, unless it not become the 0 we have. And that means if we say a multiple root has a order of multiplicity m, so what does this mean? This means its mth derivative not equal to 0, but all previous derivative must equal to the 0 we have here now. That's the condition generally we use here. But if we want to use this condition, we must be guaranteed that alpha must be given. If alpha is not given, we cannot use this rule to find out the order of multiplicity. This example, I think we finished last time. Let's, as I told you, to find approximation of the order of multiplicity, the approximation of the multiple root, we have to use only one method, which is called modify Newton method. And I give you the modify Newton method, two shape. One with m, which is a very simple shape, but we need m. What is m? M must be greater than 1, which we call the order of multiplicity of the multiple root. And m we can only find out, as I told you, if we are given alpha. And if alpha is not given, we cannot use this formula. We have to use the second shape of the formula, which is this one without m formula. This is slightly lengthy formula, but we have no choice. If we are not given alpha, we cannot use first shape of the modified formula. We have to use this second shape, which we call second modify. But of course, in exam, teacher never mention use the first modify or the second modify. You have to decide by yourself which one you have to use. First modify, the second one, it only depend on the alpha. But if alpha is given, you can also use this one, but no need for that one, difficult. If alpha is given, always go for this one, the first choice, which is this one. But if alpha is not given, then definitely we have only one choice, which is the second modified things. Let's do some example for this one. Let's say start with some simple example, then we continue with that good one. Let's say give this example in the exam one time here. He say, show that the modify Newton formula for the triple root of the equation is this one. This is a modified formula for the triple root What is triple mean? Triple mean the multiple root is repeating 3 times. Multiple root is repeating 3 times here. So multiple root is what? Is 2, and it's repeating 3 times. That means m is given by the teacher directly. No need to find yourself. Here directly he give you m, which is 3. So what you have the formula? You have the formula is this one. You are given x, you have xn minus 3, f is given, f dash you have to find, then you have to simplify and you can get the formula. So he say this is a Newton, modified Newton formula for this condition, triple root of alpha. So you can do what? This is what given by teacher. He give you f, because anything left hand side of the nonlinear equation is your f. You need to find the derivative. What is the derivative of this one? Is the 5x 4 minus 32 plus 75 and 76x and 28, which I give here now here. So you have to start from here. This is your f of x given by the teacher, and you need to find the derivative, which is this one here. Then you put in the formula. In the modified formula is xn minus m. M is given 3. This is f and this is f dash. And now you can simplify this one by taking the LCM same. You know this one here. We can write here a. We know what is the meaning of a minus bc. A minus bc we can write here by cross multiply ac minus b taqsim just c. We take the same LCM. We can write here AC minus B taqsim by C. Or if you don't understand this one, we have A minus BC. We want here, what is we have in the denominator 1. But we want the denominator same like the other one, C. So we multiply C in the up and down. So we can have this one, exactly the same thing. Because when you multiply something up and down, so we can cancel, we have the same original form. So when we have this, now you can have C, same LCM, we can have write this one here. So this is the things you have to do here. You multiply this one by up and down, then you have the same LCM, simplify, and inshallah you will get this shape which teacher says show that this shape is the modified shape for this problem. Then he can say what is the next part? He say use x naught is equal to 2.3 to find the third approximation of the multiple root alpha equal to 2. So how can you do that one here? Now you have the shape is this one. You use this shape 3 times by putting n is equal to 0, 1, and 2. Then you can have here. Now you can see how good approximation. What is your multiple root? Is it 2? And what is this approximation? After just third iteration, you have this one. And now you can check your value of the function at this 2.00 is how much? 10 minus 15 accuracy just after the third iteration. Therefore, I told you for multiple root, modified Newton is the best one we have here now. Let's take another example, which I give here now, because in the first example, I give you the alpha, but in the second example, this one, I not give you the alpha. I say use second. Of course, as I told you, I never mention in the exam first or second one. You have to decide which you will use. I will say use the modified Newton method to find the first approximation to the multiple root of the nonlinear equation using x naught is equal to this one. Now you can see here, you are given is not the exact multiple root. It is not given by the teacher. It's mean you cannot use the first shape of the modify with the m here, because when alpha is not given, I told you, you cannot find out m. It means the only choice you have to do is this one, to use this shape. But when I gave this problem in the exam, some student did what? They find out the exact root, which is very simple. Exact root is a 0. because cosine 0 is what? 1. So 1 minus 1 is a 0, so is a. But exact root, I told you, you don't have to find out. If you need exact root, must be provided by the teacher. So what they did, they find them the exact root and then they use the formula m. And of course, I didn't give them the marks here because you are not supposed to find exact root. It's mean the only choice for this case is to use this second, the shape of the formula, modified formula here, and which I did. You need, this is your f directly given by the teacher. F is your 1 minus cosine x. So you need the first derivative, which is sine x, and the second derivative cosine x. So put the value there, and this is the shape of the modify formula for the given problem. And then he say use this formula to find how many approximation? Just one. So use this formula to find one. So that's the jawab you have here. This is the things we have here now, please. Let's take one more example. This is, I give 2-3 times in the exam here. But in exam, in this book, I'm solving this example for all 3 cases. 3 cases what? 2 for the modify case, and 1 we use a Newton method. And I told you Newton method is not a very good method for the multiple root. Newton method only good for the simple root. But I just show you this one, why Newton is not good for the multiple root. My question is what? Show that the function directly give you the function. If we put this is equal to 0, this means the non-linear equation. The function has a 0 of multiplicity 3 at alpha equal to 1. So that means you have to find this function has a multiple root, a multiple 0, which is alpha equal to 0, and it's repeating 3 times. So how can you find out repeating 3 times? As I told you, we have to use the lemma, which I give you 2.2 before. You have to take the highest derivative unless your highest derivative never become 0. So first we do this part, then we come to the second part. So we have given is what? This is the multiple root given here. You find f of x, you find first f at 0. F of 0 is 0 because e power 0 is 1. This is 0, 0. 1 minus 1 is a 0. Yes, it is guaranteed, it is a root. Now to check its multiple root, we take the first derivative. The first derivative of the function is this one, and then check first derivative at 0, which give you 0. This 100% guarantee it is a multiple root. When you have a multiple root, you need how many times it's repeating? Alpha is given. So it means you can use the lemma 2.2, which I gave you. That means you have to continuously take the highest derivative unless it not becomes 0. Second derivative of this one, this is not what? Is ex minus 1. You find the second derivative, which again becomes 0. Continue. Find the third derivative, which is ex. And third derivative is not equal to 0. It means your multiple root is repeating how many times? The highest derivative we use, third. So it's m equal to 3. We finish the first part. The second part, he give you what? Then find the approximate solution of the 0 of the function with the help of Newton method. First and second modify Newton method by taking the initial approximation x not equal to 1.5 within the accuracy 10 minus 4. Please, I repeat again, in exam, I will never give you 3 methods at a time. In exam, only one. But here I want to show you modify first or second one. They give you the same accuracy. And Newton give you slow and modify give you the. So first I use the Newton method with the given initial approximation 1.5. I need first, second, third, and I need up to what? I need 25 iteration to get the accuracy 10 minus 4. But if I want to 10 minus 4 accuracy by first modify Newton method with the m, I need how many? Only 1, 2, and 3. And if I use the second modify Newton method, how many I need? 1, 2, and the 3. Same accuracy for the modify. But you can see the modify, both are. Now, when I say same accuracy, it doesn't mean that you have the same job for the both cases, the first and second. No. What is the exact solution? What is your exact solution? Is 0. What we get here? 0.005 times 0, 1, which is very good one. And what is here? 5 times 0 and minus 5 times 0. And then we have 0.000005 times, and then we have a 37. But negative, no problem. Exact solution is 0. This is coming to close to 0 from the left hand side. This is coming to 0 from the right side. We don't care coming from left or right. We want should be close to the 0 in this case. And now you can easily say the modify is the best one. So this is, I just say here, generally mean 99.9% chance Newton method is best for the simple root, and modify is best for the multiple root. Multiple. Right. Now, but when I give this example 2-3 times in the exam, of course I will only give you one. This is the way I give you the problem in the exam. I say, show that this equation, I give this equation, show that this equation has a root alpha. Same example, right? Show that this equation has a root alpha. This is the first part. Then I say use best method to find the first approximation by using x naught is equal to 1.5. Now please, I say this one has the best method. Now, how many best method we have up to now? We discuss, please. Anyone?
2.
2. One for simple root and one for
multiple.
The multiple. Now, teacher only mention it has a root, but teacher never mention is a simple or the multiple. It's mean before you have to decide which method I will go for it, you have to check given root is a simple or the multiple. And I told you very simple rule. You simply take the derivative of the function. If the derivative of the function at the given alpha is 0, it means multiple, not equal to 0, it means simple. Now we'll check here now. First, originally things we have to do what? We find the f of x, which is the same one here. Take all the term on one side, make one side equal to 0. And then you check function at 0. When you put here, you have the jawab 0. Yes, it is the root. 0 is a root. Now when he say has a 0 root, then he say use best method. So after this one, we have to check by ourselves. Teacher not mention you, but you have to check, must be checked. This 0 is a simple root or the multiple root. And for this one, what you have to do, please, you have to find the first derivative of the function. And your first derivative is what? This is your first derivative. Check first derivative at the alpha, which is 0, and which is equal to 0. Now it is 100% guarantee. What is that? Multiple. So it means when alpha is given, I told you always use a modified shape with the m. So you need to find out m. And how to find m? This way I find m. Your third derivative should not be equal to 0. It means m is equal to 1. And now when you have this, your formula become what? Your modified formula become to find first approximation is what? X naught minus m
minus, sorry.
Right? M is 3. And then we have f of x naught. Taksim
Same derivative.
Derivative we have here. F of x naught, same f dash x naught. Now x naught is given by the teacher is a 1.5, and when you use, inshallah, you have 0.203, which we solve here. This is the first modify formula we use, 0.203. This is the jawab. This is a wave problem given in exam. Of course, in exam, teacher will not give you all three possible cases. I only give you here to only show you that why Newton method is not suitable for the, but remember that one, for simple root, we can use also modify. But of course, for simple root, if teacher say the best one, always use the Newton method. If for the multiple root, we can use bisection, we can use fixed point, we can use Newton, we can use secant. But of course, the best one always the modify Newton methods. Now let's say I give here this one. I give this one example. Let's say this one. I say this is only I want to check here now. Of course, this is only for your information. I say find the root of this one. How many root this equation have we have?
3.
It must have a 3. My question is what? This one has a 3 root. Can we find its approximation and check which one is a simple and which one is the multiple, right? So how can you check which one is simple and which one is multiple? Don't use that first derivative, right? You use Newton method and modify Newton method, right? And which give you the good accuracy? We say that is the simple root or the multiple root. Like so I will do this one. I use this initial approximation, x naught is equal to 4. I use what? First I use Newton method. And this is the Newton method we have. For Newton method, we don't need m. We have x, and this is your f given by the teacher. This you computed, which is the first derivative. You use here, and you find x1 is this, and you find x5 is this one. Now I use the modify, and of course I cannot use the modify Newton formula with them because we don't know alpha. I use this one, and I find also x5, we have this one. Can you have some idea which will be the root you have?
Simple.
Which will be the root we are discussing?
3.
Is a 3. The root we are discussing is a 3, and 3 we have, because this is almost, because when you approach to the root, there will be no big change here. So that means we approach to the root. So here we approach to the root after 5 iteration 3 by the Newton, and here we approach 5 and 2.9. Which one is good one?
Newton method.
The Newton one, because he give you the 3 here. So it's mean now you can simply say this equation has one of the root of this one is a simple, which is the 3. Now I change my initial approximation, x is equal to 0, and then I check. I use Newton method, and I find x6 is equal to 0.977, and same initial approximation I use for the modify formula, and I have what? 3 iteration is this one. Can you see what is the shape of the alpha you have for this case?
1.
Is a 1, and your 1 should be what? Simple or multiple? Which give you the good one? Modify Newton give you the 1. So this one 1 must be the multiple root. Why multiple root? Because modify give you a good approximation as compared to this. This took 6 to give 0.9, but this give you 3, only 1. So that's a multiple. This is one other way approach to the idea of the multiple root, because if you have the alpha is given directly, no need to do this one. We can simply check f dash alpha is equal to 0, it is multiple root, not equal to 0, it's a simple root. When alpha is not given, we can also check what root is a simple and what, which one is the multiple. You got, please? Any question up to now? Up to now, I didn't give you the difficult example. Let's I give you example which I will give you in the exam, or which mostly come in the exam here. This is a example, one of the best example we have for the case of this. Now, before one thing, let's say I ask you one question. If I say some method is converge fast, how can you check that one? If I ask you, check your method is converge fast.
G dash of
Yes.
alpha, absolute value,
Yes, is equal to
0.
yes. That's the way we have to check this one. Always remember that one, please. This is a condition I give you when we discuss fixed point. The question is this one. The equation 1 minus 2 cosine x plus cosine square has a root. Let's in exam I mentioned directly has a multiple root. This is the first part. Then I say the second part, develop means find the modify Newton formula for computing this root. This is the second part. Then the third part, after you develop the formula, use that formula to find out the to find the second approximation by using initial approximation. This is the third part. Then the fourth part, show that the developed formula, which you develop for modify formula, converges fast. But in the book, I mentioned how you to show this converge fast by using this condition. But in exam, I will not give you this condition. You must remember that condition. How you can say converge faster? That means G dash must be equal to 0 at the alpha. But in the book, I mentioned here. Right, okay, let's come now to the solution. What is your f of x given? Is this one. Now you need to what? To check the value of function at a given alpha must be 0, because he said show that it has a root. Then we find out f of 0. We know cosine 0 is 1. So 1 minus 2 plus 1 equal to 0. So we can have here. Now, before to make the derivative also, so I just simplify this one. This is a complete murabba we have here, and a complete square we have 1 minus cosine square. And when you open this, the square, you can have this, because we know the formula a minus b square always equal to what? A square minus 2ab, which is this, plus b square. We have this one. But this is for easiness. We have to take the derivative. Now, he say develop the modify Newton formula. Modify Newton formula is this one. When alpha is given, always we can find m. So it means we need m. How to find m? We have to continuously take the derivative. And when we take the derivative, we have to stop when our order of derivative is not equal to 0. So it means when you find the first derivative, check 0. It gives you the guaranteed multiple root. When we find the second derivative, it is 0. So we continue. Find the third derivative, it gives you the 0. We continue. And after checking fourth derivative, It is not equal to 0. Which order of the derivative is not 0? It's 4. It means your m is 4. M4 mean your alpha equal to 0 is a multiple root and it is repeating 4 times. And then you put the value of f and f dash and m. We already know f. We already know f dash here. And we already know m now. Sorry. We can put here now and we simplify. We have this. This is the Duell formula. He said, Duell, find the Newton formula for this case. This is the Newton formula. Xn plus 1 equal to xn minus 2, 1 minus cosine xn taxim by sine x. So this is the things we have here now. What is the third part now? The third part he say, after you develop the formula, then use it to find the second approximation by using x0. Now you can use this formula 2 times. X1 give you this, x2 give you this one. Very good accuracy. 10 minus 7 accuracy just in the second iteration you have here. We finish the third part. Now the difficult part come now. He says, show that the Duell formula converge faster, but not this one. So when he said Duell formula converge faster, and we always check the formula converge slow or faster, we need always g of x. And I told you how to find g of x. Anything on the right hand side of xn plus 1 will be your g of x here. So what is your g of x here? This is your xn plus 1 and this is your right hand side. That is your g of x. Now you can find, as I give you g of x. Now you take the derivative, right? And we know derivative of x is a 1. And you use a quotient rule here. You know the quotient rule you did in math 150, f taxim by g derivative. This is I use here. And we have this one. Now you check g dash at 0 because alpha is 0. When you put at 0, you have cosine 0 is 1. So 1 minus 1 is a 0. Sine 0 always 1. So we have a 0 by 0. Undetermined term. Undetermined term is what? Is 0 by 0 or infinity by infinity we have here now. If you face this type of limit, what is the problem? Which rule you use to solve it? You did in 106, I think.
L'Hopital rule.
L'Hopital
Rule we have to use. L'Hopital rule mean we have to take the derivative of up and down separately. So we do like this one. Use L'Hopital rule. We find the derivative of this one and then check the derivative as 0. Then again we can see sine 0 is 0 and cosine sine 0 is 0, 0 by 0 again. So it means we continue to use the L'Hopital rule unless we have a real number jawab or infinity. And we continue inshallah. After that we have the jawab is 0. And you know that g dash 0 always mean what?
Converge fast.
This converges fast. That we show the convergence is very fast. So that's a very good example from examination point of view. First he say, you develop the formula, then he say, use the formula, then he say, the Duell formula is converge very fast, or maybe he say converge formula is slow. I give this problem in the 2-3 times this problem. One time I give this problem in the exam. I say this equation has a root alpha equal to 0. And I say develop Newton formula for this case. Develop Newton formula for this case. And then I say check that the Duell formula converges slow or fast. So how can you do this problem? You will do the same thing. The only things you have here now, what is your m here in the case of Newton? It should be for Newton method, please. What is the value of m?
1.
1. So we have no need for here. So we can have, when you do this one without this one, you have the new shape you will get here, and that is the shape of the Newton. And when you find the Newton shape, then you find g by the right hand side. And when you take the derivative, what jawab will be you will get, please? When you take the derivative of g, what jawab you will get? You see, no. When I take attendance, everyone will be ready now. Majuz here. Now, when I ask question, no one give me the jawab here. This is a multiple root. And multiple root, I told you the modify method is the best one. And the best one means g dash must be equal to 0. And Newton method is not a best. And when Newton method is not best, what is the value of g dash? G dash should not
Greater
be
than 1.
equal to 0. It means when you solve this problem with the Newton case, your jawab is g dash is not equal to 0. Any number you have here, but not 0. It means if the g dash alpha is not 0, it means it is not a faster convergent method. It's a slow and should be slow, because I already told you the Newton method is slow convergent method. And also I give this question 2-3 times here. And what is the faster convergence method? Remember I told you last time here, sometime I say use the best method, or I say use the quadratic convergent method, or I say use the faster convergent method. The same meaning, please. The best method, the quadratic convergence method, and the faster convergence method. So this is the same meaning. If I say use the slow convergence method or linear convergence method, same meaning. Slow or linear convergent method means slow here. Last time I confused, the student confused in the exam. I give this same problem. I say this equation has a multiple root. I mentioned multiple root directly here. This equation has a multiple root, alpha equal to 0. And I say use the linear convergent method to find the first approximation or the second approximation. I repeat again, please. You should be the very good point here, this one. I say this equation has the multiple root, alpha equal to 0. Use linear convergent method to find second approximation. Which method you will use now?
Newton.
Newton, because linear always means slow. And we know for the multiple method, Newton is a slow method. But a student, they say you mention is a multiple root, and multiple root, the best one is always the modifier. Then I say I never mention the best one. Best one, if I want, I mention quadratic case or faster convergence. I mention the linear. Linear convergence always mean the slow.
Doctor,
Yes.
can I use the other method
Which one?
if you mention slow convergent or linear?
You can use any method for this one. The
Okay.
fixed point, the bisection method. But this become very, very slow. Therefore, we pick only the best one from the simple case, which is a Newton one. Therefore, we just use the linear Newton.
Okay.
Right?
Okay.
Because I told you, all the simple root method, fixed point, bisection, Newton, and secant, we can use also for the multiple case, but it's useless because they are very slow, because we pick only the best from the simple, which is a Newton, and Newton is very slow. What happened the other one, which is already slow for the simple case? Okay. So this is, we call the story of the multiplicity of a multiple root we have here now. So we finish the idea of the root now. To discuss idea of the root, please, what we need, I just give you the revision now. For the approximation of the root, we need nonlinear equation. We need to check it is simple or multiple. If it is simple, we have a 4 choice to use it to find its approximation: bisection method, fixed point method, Newton method, and the secant method. And among this, the best one is the Newton one. And for multiple root, we can use all also this one, but the best choice for multiple root is the modified Newton method. And the modified Newton method, I give you two choices of the modified formula, one with the m and one without the m. M for choice we can use only if we are alpha is given, and if alpha is not given, we cannot use the choice with the m. We can have to choose choice without the m we have here. Now we finish that part of the things here. Any question you want, please? Okay, let's move to the next topic we have here now. So it's mean up to now we need f. Whatever we finished up to now, we need, the important thing is what? F of x now. Now we talk new topic. It's second last topic of the chapter number 2. And when we finish the chapter number 2, we finish our first short test, which is coming, I think, in the third week of February, the 23rd. It will be 23rd of February, and it will be during the from 8 to 9 time, not 1 hour exam, maybe 40 minutes, maybe 45 minutes. I will give you how many questions I will choose. That I will tell you later on, inshallah. That the whole chapter will come in the first short test here. Now, the convergence of the iterative method. Now, what is the convergence of the iterative method? Order of the convergence or speed of the convergence method. In this topic, we will only discuss why one method converges slow and why one method converges fast. It's mean in this part, we don't need nonlinear equation. And when we don't have a nonlinear equation, it means we have no f of x. Can any student give me idea like what we need here in this part of the things? When we say we have to check order of the convergence or speed of the convergence, what we need?
The g of x.
Yes. So of course, in this topic, we are always given what? The iterative method. What does the iterative method mean? Iterative method mean n plus 1, I'm right, equal to what? Gxn. We are always given this one now in the throughout. This g will give you xn equal to this. This is the iterative formula, any formula we have here. And what we have to discuss here, we want to check, this is any iterative method. This iterative method will converge slow or fast. So we have to check. Teacher give you the method and he will ask you, check its order of convergence. Order of convergence mean it converge slow or converge the fast. It's mean to check slow or fast, we never need f. We always need g of the x we have here. So please, a student always confuse with order of convergence and order of multiplicity. Please, order of multiplicity, we already finished. What is the order of multiplicity mean? Order of multiplicity mean your multiple root is repeating how many times? And order of convergence mean your method is converge slow or the fast. Please this one. For order of multiplicity, we need f. And for order of convergence, we need g. That's the difference. Please, but student always confused with that one here. And let's I give you a small idea here, then we continue inshallah next time here. Now this is the formula to check order of convergence, and which is the definition, this one. This is the definition, and this definition slightly difficult to use here, but this is the original definition, and then I will give you the shortcut. What is can you give me, what is the original definition of the multiplicity? Any student, please. I give you the original definition of multiplicity, how to find out, which I say this is difficult.
X minus alpha
Power m
power m.
into h of x. This I say, this is the original definition of finding the multiplicity, but this is very difficult. This is only simple if you have a simple polynomial function. Otherwise, it's very difficult. Then I give you lemma 2.2, which is a very shortcut. That means you have to continue to take the derivative of f unless your derivative of f is not equal to 0. Now here by definition I give you, which is difficult here. Then I give you next time the shortcut here. What is this one? We say suppose that the sequence means the approximation. An approximation we always find with the help of the method. The sequence converges to the exact solution with this condition that alpha exact minus approximation taxim by exact minus approximation at xn. This is xn plus 1 xn, and this is equal to some constant. What is alpha? Exact, this is approximation, and exact minus approximation always mean error, which I write here, error, E for the error. This is error in n plus 1 step. This is error in n step. So when we take the limit of this one, then this power r is called the order of convergence. That means if you use this one and the jawab is a constant, then this power r is called the order of convergence. So it's mean in order of multiplicity we need to find m, and order of convergence of iterative method we need find r. And generally, basically, we discuss in our this chapter, r may be 1 or 2. When r is equal to 1, the method is converge slow, linear. And when r is equal to 2, the method is converge very fast. This is the things we have to do. So when we say r equal to 1, it's mean very slow convergent method, linear convergent method. When r is equal to 2, it's mean very fast convergent method, or we call quadratic convergent method. But to find r by this definition, 90.9 is very difficult. I give some example to find r by this way, but in the exam I will not give you here. I give you the simple way to find the value of r and 2, which is very, very simple. You can only check in 1 second, 2 seconds, like that one here. That I will give you. This is the things I give you here. When r is equal to 1, the convergence of the sequence is called the linear convergence. Linear convergence always means slow. And if r is equal to convergence is 2, the convergence is a quadratic. And of course, the same way, you can have r equal to 3, r equal to 4. As you have the highest value of r, your method becomes faster and faster. But we discuss only 5 numerical methods, and their maximum speed of convergence is what? The 2. Therefore, I just take this one. How to find this r in the short way, that I will discuss inshallah next time. Okay, any question, please, before I take your attendance?